Hello dear learners, myself Professor Jitendra Sarova from Department of Geography, Dr. Bhim Rao Ambedkar College, University of Delhi. Today I am going to elaborate upon a very important topic, that is growth and historical development of oceanography as a science. How oceanography has evolved over the period of time. So focus will be on this particular aspect, and it is part of unit 1 of your core paper of oceanography in MSc Geography IGNOU program. Throughout history, coastal cultures have gained the knowledge of sea waves, tidal fluctuations, winds, and ocean currents from time immemorial. Ocean transportation provided them benefit of mobility and nutritional advantage due to proximity to the sea. The Polynesians practiced and perfected their seafaring understanding. They traded over long distances and colonized distant islands in the Pacific Ocean as early as 4000 BC. The remarkable discovery of Lothal dockyard of the Indus Valley civilization, which shows India's maritime heritage and maritime trade connections of time around 2400 BC. The association of tidal fluctuations with the movement of sun and the moon and changes in their relative positions were described very well in the Samved of the Indian Vedic period, which belongs to around period 2000 to 1400 BCE. The first direct proof of voyaging, that is the practice of traveling on the ocean for a particular purpose, was found along the Mediterranean Sea, and it is provided by the trade records. The first regular ocean traders were probably Cretans, followed by the Phoenicians and the Egyptians. Greek scholar Pythos, in his account of voyage time period around 325 BC, called On the Ocean, described a sea journey to Britain, the North Sea, and the coastline of northeastern Europe. The curiosity and the commerce encouraged adventurous people for ambitious voyages, but success of these voyages required knowledge about astronomical determination of direction, shape, and size of the earth, vessel building technology, and precise marine graphic charts. In this direction, the Library of Alexandria addressed these concerns in past and provided the base for systematic study of the ocean. The earliest known bathymetric studies, that is about depth of the oceans, were carried out in the Mediterranean by the Greek scholar Posidonius in time period around 85 BC. In India, the Gupta dynasty, time period around 320 to 520 AD, and the southern dynasties of the Cholas, the Cheras, and the Pandas, during 3rd to 13th century established strong maritime trade links with Southeast Asian countries and applied the knowledge of monsoon winds in sea voyages in this particular area. In the Middle Ages, the Arab traders applied their understanding of the reversing winds, that is monsoon, and the currents of the Indian Ocean to establish strong trade routes to India and China, and later on also to Zanzibar on the African coast. The Chinese, with the world's greatest fleet, undertook 7 missions during the time period 1405 to 1433 AD to explore the Indian Ocean, Indonesia, and also around the tip of Africa in the Atlantic. Their success was based on inventions such as the compass, the central rudder, watertight compartments, and sophisticated sails on multiple masts. Despite these advancements, they officially abandoned oceanic exploration in 1433. Modern European knowledge of the ocean began and gained momentum during the age of exploration, that is between 15th, 16th, and 17th centuries. Prince Henry, who is known as Prince Henry the Navigator, promoted sea exploration for trade and wealth, and he established a center of study for marine sciences and navigation. The leading explorers of this time were Bartholomew Diaz, Christopher Columbus, Vasco da Gama, and Magellan, and there were many others. They laid the foundation of global trade routes based on their understanding of prevailing winds and ocean currents. Scientific oceanography began with Captain James Cook's voyage on HMS Endeavour, in addition to asserting the British presence in the South Seas. The expedition had numerous scientific goals: New Zealand, Great Barrier Reef of Australia, and various islands were charted and mapped during this particular expedition. In the second voyage with Resolution and Adventure during 1772 to 1775, the ships charted Tonga and Easter Islands and discovered New Caledonia in the Pacific and South Georgia Island in the Atlantic Ocean. In his third expedition in Resolution and Discovery vessels in 1776, he explored Canada, Alaska, and Siberia part. Cook deserves to be considered a scientist as well as an explorer because of accuracy, thoroughness, and completeness in his descriptions. In accurate determination of longitudes for ocean exploration and mapping, the Harrison's chronometers and recognition of Greenwich meridian in 1884 as zero longitude played key roles. The United States expedition during 1838 to 1842 on the board flagship USS Vincennes and the expedition's 5 other vessels under Wilkes' team confirmed Antarctica as a continent, and James Dana confirmed the hypothesis of Darwin regarding coral atoll formation, which was basically related to the subsidence theory of coral reef formations. This expedition helped in establishing oceanography as a natural science in USA. Franklin in 1769 published the first chart of any ocean current, and that ocean current is well known, Gulf Stream. Matthew Maury was the first person to identify the global pattern of surface winds and ocean currents. His discoveries, published in The Physical Geography of the Seas, which was published in 1855, gave him the recognition as the father of physical oceanography. He was perhaps the first scholar to conduct the systematic study of ocean as a full-time professional. The Challenger expedition, which is very well known, of time period 1872 to 1876, was the first sailing expedition devoted completely to marine science, was conceived by Charles Wyville Thomson and Sir John Murray. The scientists of this expedition called this enterprise Oceanography and collected and analyzed data about salinity, temperature, water density. They discovered 4,714 new species and proved Forbes wrong that presence of life is also there at greater depths. The Challenger report, which was published between 1880 to 1895, the record of expedition came in the form of 50-volume set by Sir John Murray, and this particular record provided or laid the foundation of the new science of oceanography. Modern oceanography gained momentum with modern technology based scientific explorations and investigations of the deep sea floor and polar oceans. Nansen, in his specially designed ship from time period 1893 to 1896, explored the Arctic region, and his observations of drift, of weather conditions, and ocean characteristics of marine life at high latitudes based on deep sounding and sampling techniques proved the way for modern polar science. His student Ronald Amundsen in 1910 successfully conducted Journey of the South Pole. The German meteor expedition of 1925 applied modern optical and electronic equipment like echo sounder to map the topography of the sea floor. In the second HMS Challenger expedition of 1951, the deepest part of the ocean was identified and it was named as Challenger Deep. In 1960, it was visited by Don Walsh and Pickard in a bathyscaphe. Deep sea drilling and analysis of seafloor sediments provided scientific evidences in support of idea of seafloor spreading and the theory of plate tectonics. Further, in 1985, deep sea drilling were conducted with the help of technologically advanced ship JOIDES resolution. International Research Consortium, the Integrated Ocean Drilling Program, that is IODP, was handed over the responsibility to conduct deep sea drilling. In 2010, the National Oceanic Atmospheric Administration, that is NOAA's new Oikonos Explorer started using remotely operated vehicles, and applications of robotics in oceanography gained significance. Thus, slow ships of the 19th and 20th centuries have been replaced by satellites, drifters, and autonomous instruments, and data from these advanced techniques are processed in a numerical models for Earth as a system. The understanding and exploration of the ocean can be divided somewhat arbitrarily into various eras. This exercise was first conducted by scholar George West in 1964, and it was later on updated by scholar Stewart. So, on the basis of these two contributions, we can, and contemporary situation, we can identify 7 eras which resulted into the growth and development of oceanography. The first era is named as era of surface oceanography. This era, from the earliest times to around 1873, is characterized by systematic collection of observations of winds, currents, waves, tidal fluctuations, temperature, and other phenomena observable from the deck of the vessels. Notable examples include Halley's and Hadley's charts of the trade and monsoon winds, Franklin's map of the Gulf Stream, theory of tides by Laplace in 1775, and Matthew Fountain Maury's Physical Geography of the Sea, published in 1855. So it was basically limited to the surface part of the oceans. In the second era, which is known as era of deep sea exploration, this era extended from 1873 to around 1914. It is characterized by a few wide-ranging oceanographic expeditions to survey surface and subsurface conditions. The major example in this era are Challenger expedition between 1872 to 1876 and Gazelle 1874 to 1876 and Fram expedition 1898 to 1902. So they provided data of deep sea areas. The third one is era of national systematic surveys. So now oceanography was gaining momentum, and at national level it was realized that surveys should be conducted. So this is era of national systematic surveys, and this belongs to time period around 1925 to 1940. This era is characterized by detailed ocean surveys. Examples include meteor surveys during 1925 to 1927 of the Atlantic Ocean, mainly by the Germans, and the Discovery expedition, which is officially known as the British National Antarctic Expedition by the Britishers. The fourth era is known as era of new methods. This era extends mainly from 1947 to 1956, and it is characterized by long surveys using new instruments. Examples include seismic surveys of the Atlantic by the Weema and discovery of Weema fracture zone by Hamilton, and later on the Weema seamount in the South Atlantic Ocean. So this was the phase of new methods. Gradually from national to international, oceanography gained significance. So fifth era is era of international cooperation. So this era extends from 1957 to around 1978. It is characterized by multinational surveys of ocean and studies of oceanic processes. Examples include the Atlantic Polar Front Program, the NORPAC, that is North Pacific Survey by agencies of USA, Japan, and Canada. The International Geophysical Year was recognized in 1957-58, and 1971 to 80 was recognized as the International Decade for Ocean Exploration with international cooperation. So the fifth era was related to international cooperation. The sixth era is era of satellites, that now instead of sensing from surface, sensing from water or beneath water, sensing from the space. So this is era of satellites, and it basically belongs to the time period 1978 to 1995. During this phase, during this era, global surveys of ocean processes were conducted from space. Examples include CSAT, satellite data. CSAT was launched by NASA on 28th June 1978. NOAA's satellite 6 to 10, Nimbus 7, launched in 1978, GeoSat of 1985, Topax and Poseidon 1992, and ERS, that is European Remote Sensing Satellite 1 and 2, and even today new satellites are launched and their resolution is also very high. So the seventh era is the era of Earth system science. This era basically began 1995 onwards. It is characterized by global studies of the interaction of biological, chemical and physical processes in the hydrosphere and atmosphere and on lithosphere, because now Earth is visualized as a system. Examples include the World Ocean Circulation Experiment, that is WOCE, and its field phase was between 1990 to 1998, and analysis and modeling phase of the data generated during this period was up to 2002, and TOPAX or Poseidon joint venture of CNES and NASA during 1992 to 2006, which enabled scientists to forecast 1997-98 El Nino and improved understanding of ocean circulation and also its effect on global climate. And likewise, the Joint Global Ocean Flux Study, that is JGOFS, was also an international research program on the fluxes of carbon between the atmosphere and ocean. It was conducted from 1987 to 2003. Similarly, the Global Ocean Data Assimilation Experiment GODAE was conducted from 2003 to 2005 with the goal of making routine ocean monitoring and prediction an operational activity like weather forecasting. Further, in 2016, the first World Ocean Assessment of the United Nations stated that humankind was running out of time to start managing the ocean sustainably. The United Nations Decade of Ocean Science for Sustainable Development is going on. It started in 2021 and it will last up to 2030. The present decade is the United Nations Decade of Ocean Science for Sustainable Development, and it gives primary significance to ocean science and ocean governance. So we started with surface exploration, surface observation, then moved to water part, density, ocean currents, salinity. Then scholars they moved to the surface of the oceans, and now 2013 onwards up to 2024, International Ocean Discovery Program is going on. Similarly, between 2003 to 2013, International Ocean Drilling Program was conducted with international cooperation. So now we are moving to beneath water. What type of surface conditions, subsurface conditions, they prevail over the oceans. So this way, over the period of time, from local level observations, we have moved to global level observations, and observation of single phenomena, we are now trying to interlink all the phenomena and trying to understand with global cooperation the connectivity of oceans with all other spheres like lithosphere, atmosphere and biosphere. So we are trying to study Earth as a system, and definitely oceans are a key component of this system. So that's all. Thank you very much. Thank you.